Okay, so problem number 1 says for a period of time, an island's population grows at a rate proportional to its population. If the growth rate is 3.8% per year and the current population is 1,543 people, what would be the population in 5.2 years? So since the island's population is growing at a rate proportional to its current population, this is going to be an exponential growth. And we know that the formula is going to be A is equal to A naught, which is the initial population. Some books use P instead of A. It really doesn't matter. It's the same formula. So if you see P is equal to P naught, it's the same thing. And I'll probably use those interchangeably during this video, just so you know. And then we're going to say E to the KT, or CT, where C is a constant and T is time. Now we know that the initial population, or the current population, is 1,543. So that's going to be the A naught value, or the P naught value, depending on which letter you choose. So I'm going to substitute 1,543 in place of A naught. And of course, E is a number, right? It's about 2.71828. E is on your calculator, just like pi is, and you need to get familiar with it. It's on the left column of the calculator, about the third row from the bottom. Now, C is going to be the growth rate, and since it's growing, I know that C is positive, and it's going to be 3.8%, which I have to write as 0.038. Remember that we always use a decimal, not percentages, so 0.038. That's going to be C. And of course, time is going to be 5.2 years, so I will have to use 5.2. And as you can see, the answer is already there, but I just wanted to explain how we got the answer. And now all I really need to do is just type this into the calculator. And that's going to give me approximately 1,180. I'm sorry, 1,880. I was wondering why the population went down. Okay, so type this into the calculator and you will get 1,880. So that means that in a little more than 5 years, the population on this island will go from about 1,453 to close to 1,880 people. Okay, let's take a look at problem number 2. Problem number 2 says, during an exponential phase, E. coli bacteria in a culture increases, so I know I have a growth, in a number at a rate proportional to the current population. If the growth rate is 1.9% per minute and the current population is 172 million bacteria, what will the population be in 7.2 minutes? Okay, same formula, right? Now, in problem number 1, I used A and A naught. I could also use P and P naught, probably the one you would most commonly see. So the amount of bacteria that you would have at any time is dependent upon how much you start with, right? So we'll call that P naught, and of course you'll have E to the power of CT. And notice that the current population is 172, so we would plug that in here for P naught, which is what they did here. And then of course C is 1.9% as a decimal would be 0.019. That's where they got this from. And then, of course, 7.2 is in minutes, so that's the time. So what does that mean? That means that if you start off with 172 million bacteria and you come back in 7.2 minutes, you will then have 197.2 million. So you'll have a lot more bacteria in just 7.2 minutes. Let's go down and take a look at number 4. Problem number 4 says a savings account balance is compounded continuously, and since it's compounded continuously, we know we have to use that formula with E. If the interest rate is 3.1% per year and the current balance is 1,077, in how many years will the balance reach 1,486.73? So this time, we're trying to figure out T. And here's the answer, 10.4 years, but let's see how they would set this up. So you would say the amount, you could use A or you could use P, it doesn't really matter. I'll use A since we're talking about an amount here instead of a population. I'm going to claim that the amount is always equal to the amount you start with. And since it's compounded continuously, I have to use E to the CT or KT, depending on which book you have. I'll use CT. And I know that I start with 1,077. That's the current balance. And I know that my rate of interest is 3.1%, so that would be 0.031. That's my C value. And I'm looking for T. And I want to know, how long will it take? What would the value of T be if the amount grows to 1,486.73? Okay, try to squeeze this in here. And basically, we have to solve for T, right? We have to get T by itself. So the first thing I would do is I would go ahead and divide both sides of the equation by 1,077. If you divide the right side by 1,077, that's going to leave you with E to the power of 0.031T. And then on the right side, you have 1,486.73 divided by 1,077. That's going to be 1.38 on the left side. Now, what do we do to get rid of the E? We have to introduce an ln, right? So I'm going to take ln of 1.38. Now, what the solution manual has is probably a better answer. Notice that they're leaving it in fraction form, where I actually rounded this off to 1.38. So that what they did is going to be a little more accurate, but we're estimating anyway. So I'm going to say the natural log of 1.38 is equal to, and on the right side, if I introduce an ln, that will eliminate the E, and that will leave me 0.031T. And again, let me try to clean that up a little bit. And again, we're trying to get T by itself. So the only thing left to do is divide the left side by 0.031. So I'm going to go to the calculator. I'm going to type in the natural log of 1.38, and then I will divide that by 0.031, and I get 10.389, which is basically 10.4 years. Okay. So if you happen to invest $1,077 and the interest rate is 3.1% compounded continuously, if you come back in a little over 10 years, let's say almost 10 and a half years, then you will then have in the account $1,486.73.